Next, what we discuss is Mutex. To discuss these, I would like to mention a situation. So, when using Go routines, there may be a scenario where multiple Go routines work on shared data, and since the statements in concurrently executing Go routines execute in an interleaved manner, the end results may not be what we expect. So for example, in Golang, writing concurrently to map, if two Go routines concurrently write to try to write to a map, it is an error because map is not a synchronized data structure. So if multiple Go routines try to write to a map, it causes an error. So let's have a look at a code to better understand this. So on line number 11, we create a map and we create it outside the functions so that it is globally available to all the Go routines. So I wanted to make this a shared resource, so that is why I have declared it at a global level, so that it is visible to all the functions or the Go routines. Uh, mm, uh, Next, at line number 29, we create a function which we would use to actually spawn a Go routine, and inside the function we try to write to the map we created globally. Here we just declare the map, and just one more thing to mention: we declare the map at a global level, but initialize it in the main, because initially it would be having no value. So we initialize it and add one single piece of data to the map. So going back to our function, so we create a function which we would use to spawn a Go routine, as I mentioned, and inside the function we try to write to the map. And the reason I ran this for loop inside this function is to mimic the real life scenario where there may be multiple Go routines or multiple statements executing in an interleaved manner and trying to write to the same resource, which in our case is our map. So on line number 18 and 19, we create two Go routines from this function, and now since these execute concurrently, the two Go routines execute concurrently, there may be a situation when both of them uh, try to write to the map simultaneously. So let's try to create that scenario by running the code, and we let me just run this. So, yeah, so if you see, it says a fatal error which reads concurrent map writes. So we may not be able to generate it, although we were able to generate it in the single go, but there may be a scenario when this doesn't occur, because it really depends how the statements of the two Go routines, which in our case execute, and this error is raised only when the two Go routines try to write to the map at the same time. So let me see this time it did not result in this error, because it really depends on how the statements of the Go routines are executed by the Go runtime when in an interleaved manner. So it really depends on that. So as a solution to this, we have the mutex construct available in Golang. So mutex are basically used to synchronize access to shared resources. So each time we try to write to a shared resource, we lock the mutex to ensure exclusive access to the resource. Uh, Perform the operation on the resource, and then issue an unlock on the mutex, and release the lock for the next Go routine to maybe get the access to the shared resource, and the Go routine which just released the lock can continue executing the next instructions. So on line number 13, in this particular example, on line number 13, this example is more or less same as the previous one, with the minor differences that it uses mutex to edit the map. So line number 13 we declare our global map. On line number 16 we declare our mutex variable, which is available in the sync package, so we've imported it here. On line number 20 and 21 we initialize our map and the mutex variable. On line number 36, yes, so on line number 36 we have the same function which we saw in the previous example. The only difference being that this time I edit the map by obtaining an exclusive access to the map by issuing a lock on the mutex, and only if the go routine is able to get the lock, it goes ahead and updates the map, tries to write to the map. Otherwise it waits for the lock to be available. So when the go routine gets the lock, updates and it goes inside and it goes inside or executes the next statement where it updates the map, and after which it releases the lock and starts to execute the next instruction. On line number 25-26 we run the two go routines, and if I execute this code now, no matter how many number of times do I execute this program will never run into a concurrent write error, because we've using the mutex construct synchronized the access to our shared resource, which is map in our case. So I've executed this multiple times, so we did not see this error. You can go ahead and try it, and since we've synchronized the access, this will not this time the code will not run into a situation when we write concurrently to a shared resource.